Imagine yourself floating in the endless darkness of space. Everything is silent, calm, and peaceful. Suddenly, you notice a huge black circle ahead. No light, no stars, just emptiness. You try to move away, but something invisible pulls you closer, stronger, and faster. And once you cross a certain invisible boundary, there's no turning back. You've entered the jaws of one of the most mysterious objects in the universe. That is a black hole. Beyond the lens of a microscope lies a universe full of wonders. I am Bahar Ameer, a microbiologist. Today, we step beyond the world of cells and into the deepest mysteries of space. In this video, we will explore one of the most fascinating objects in the universe, the black hole. Let's uncover what it really is, how it forms, and why it bends the very fabric of space and time itself. What exactly is a black hole? A black hole is a region in space where gravity becomes unbelievably strong. It's so powerful that, nothing can escape it, not even light itself. That's why it looks completely black. It's not empty, it's full of matter squeezed into an incredibly tiny space. Think of it as the universe's ultimate trap. Once you fall in, you're gone forever. How does a black hole form? Let me explain it in the simplest way. First, imagine a giant star, much bigger than our sun. Inside that star, two forces are always fighting. The star fuses hydrogen into helium, and that process releases energy which pushes outward. At the same time, gravity pulls inward. For millions of years, they stay balanced, so the star shines bright and stays stable. But one day, the star runs out of fuel. When the fuel is gone, there is no more energy to push outward, so gravity wins. The whole star collapses inward very fast. This sudden collapse causes a huge explosion called a supernova. It's one of the brightest blasts in the universe. The outer layers of the star are thrown into space, but the story doesn't end there. The core of the star is still left. If that core is heavy enough, gravity keeps crushing it. It gets smaller and smaller and heavier and heavier. Finally, it becomes so small and so dense that its gravity traps everything. Even light cannot escape. And that is how a black hole is born. A place where gravity is so strong nothing can get out. So every black hole is basically the hot dead body of a giant star, a cosmic grave that bends space and time itself. Let's talk about parts of black hole. There are certain parts of black hole. First one is event horizon. This is the invisible boundary, the point of no return. Once anything crosses it, even light, it can never escape. It's like falling into a waterfall. Once you pass the edge, you're gone. And the second one is singularity. At the center lies the singularity, a point where all the mass is squeezed into an infinitely small space. Here, the laws of physics break down. Time, space, and matter lose their meaning. What happens if you fall into a black hole? Let's imagine this. You're falling toward a black hole. At first, you wouldn't feel much, but as you get closer, gravity becomes much stronger at your feet than at your head. Your body would start stretching, longer and longer. Scientists call this spaghettification, because your body would be stretched thin like spaghetti. Eventually, you'd be torn apart and disappear into the darkness forever. It's terrifying but fascinating. Do black holes destroy everything? Not always. In fact, black holes play an important role in shaping the universe. At the center of most galaxies, including our own Milky Way, there's a supermassive black hole called Sagittarius A star. It helps hold the galaxy together with its gravity. So black holes aren't just destroyers, they're also creators. They help maintain the cosmic balance. Now, how did scientists prove the existence of black holes? For a long time, black holes were just ideas, mathematical predictions. But scientists slowly gathered real evidence. In 1915, Einstein's equations showed that space could bend so much that light couldn't escape. This was the first clue that black holes might exist. And in the 1960s, scientists carried out X-ray observations, and astronomers discovered stars orbiting invisible companions that emitted strong X-rays. One famous example was Cygnus X1, the first suspected black hole. Later, in the 1990s, through galactic center studies, scientists observed stars near the center of our galaxy moving incredibly fast around an unseen object, proving there was a supermassive black hole there. Then in 2015, the LIGO experiment detected ripples in space-time caused by two black holes colliding. This was direct proof that black holes are real physical objects. Finally, in 2019, the first image of a black hole was captured. Using the Event Horizon Telescope, scientists captured the first ever photo of a black hole's shadow in galaxy M87, a glowing ring around a dark center. That image changed science forever. So, through theory, observation, and technology, scientists turned a mysterious idea into a proven reality. But why do black holes matter? You might wonder what distant cosmic monsters have to do with life or biology. The truth is, everything in science is connected. Black holes help us understand how galaxies form, how the universe began, and what rare conditions make life possible in the first place. By studying them, we explore energy, matter, and time itself, the fundamental building blocks of existence. Black holes are mysterious, powerful, and still not fully understood. They defy the laws of physics and challenge our sense of reality. Somewhere out there, a black hole waits in silence, ready to devour the next star that drifts too close. They humble us, reminding us how small we are, and how breathtakingly vast and beautiful the universe truly is. If you enjoyed this journey into the dark side of space, don't forget to like, share, and subscribe for more amazing science stories.